I hope you're well. It's Mr. Gibbs. Today I'm going to talk to you about kind of a litany of topics that relate to, climate and weather, humidity, how that impacts heat to make a hot day even worse, as well as some of the basics meteorological tools that are used to measure the conditions in the atmosphere at any given time. So, yeah, the title of it's called Weather versus Climate and the Jet Stream. Now, to start, I want to explain to you the difference between weather and climate. And look, I get it. This could be a very controversial sort of lesson. So, I'm just going to give you the information from the scientific perspective, non biased. Okay? So, weather is the conditions of the atmosphere at any given time. So it's currently 1:30 in the afternoon and outside it's sunny. Now tomorrow it could be at 1:30, it could be rainy. And next week at this time, I don't know, could be cold, colder than it is now. And what else? Well, the temperatures are, you know, whatever they should be for that particular day and time. There's a thing called an average temperature for that day, and well, that's kind of based on the next topic of climate. But to add on to that, I mean, the weather could be sunny on Tuesday and then rainy and cold on Thursday. It is the conditions in the atmosphere at that given place and time. And the weather here where I am, which is in Chesterfield, Virginia, is different, I hope, than the weather in, I don't know, Alaska. Where in Alaska? Well, I don't know. Let's go with Nome or Fairbanks. I would like to think that their weather right now is different than my weather. Now, why is that? Well, there's a lot of reasons, but we're just going to go with the fact that we agree that weather is what's going on right here, right now. Now, what else? Well, when we look at the weather, we also can view what the weather's going to be for the next few days. I give examples, and that's great. That helps you understand for the next 5, 7, maybe 10 days. And weather forecasters, thanks to really good modeling, are able to give us reasonably accurate forecasts. Now, what is reasonable? I'm going to say between 80 and 90% up to a point. Now, 10 days out, I mean, come on, really? But, 48 to 72 hours out, yeah, I'm going to say that's probably accurate. And once again, it's what's going on right here, right now. Now, climate, okay, is the mean annual weather conditions throughout the year, and it is averaged over several years. Several years. How many is several? Yeah, use your imagination. Now, this is where it gets interesting. If you want to feel that the Earth is 5 to 6,000 years old, then the climate of our planet is, as old as that. If you want to think of the Earth as a very old thing, 4.6 billion years, okay, then you're going to view climate from that perspective. But once again, it is still weather conditions averaged over years. So if you want to go with only data going back 5, 6,000 years, you're going to view the climate in that way. If you want to view the Earth as much, much older, you're going to see climate in a radically different way as well. And with climate, I mean, you would think the climate for an area, you would anticipate what it's going to be. So if I live in Florida, let's say I live in, I don't know, Tampa Bay or Tallahassee. If I live in those cities in Florida, I should anticipate really hot summers and very mild winters. If I live in Alaska, depending, it is a huge state after all, I would anticipate the climate of a weird winter and a summer that you would think is mild but incredibly short and lots of daylight, but not really in the summertime, of course, but just different. How different? I've only been to Alaska once, and it was for a small window of time. Been to Florida a few times. All I know is their climate is not where I am now. And if I go to these locations, I will like to think I'm going to do my research to figure out if I'm going to go there, what the climate will be depending on the time of year. But I can tell you that typically the farther north I go, it's going to be cooler. The farther south I go, it's going to be warmer. And up into a point where if I keep going too far south, I'll end up in Antarctica and we're starting all over again. But the climate is based on, once again, measuring data going back a long time. And we have plenty of evidence to show how climate has changed, not only in human history, but also in geologic history. Climate variability is natural. And, if you look at examples for averages for, let's say Tallahassee, you see that their average temperature in January is 65 degrees roughly, while the average temperature in July is roughly 92. So that sounds like a warm weather climate. While with Juneau, their average lows in January are much, much lower than what you would see in Florida, while their highs are actually somewhat more reasonable. So, there's this term called a snowbird. Who is a snowbird? They spend their summers in a cooler northern climate, and then they flock to warmer climates in the wintertime. That way, they never have to endure the harshness of either winter or summer. Yeah, snowbirds. So climate is averaging weather over time. And once again, how much time do you want to measure it is entirely based on how old you think the Earth is. All right, jet stream. Now, when it comes to jet stream, we need to look at what is going on. It is a fast-flowing current of air in the upper atmosphere. How high up? Oh, geez, way higher than I would care to go. In fact, it's between 7 and 16 kilometers above the surface. So we're talking anywhere between roughly 4 miles up to roughly 10 miles above the surface, because 10 kilometers is 6 miles. So 6 more kilometers is about 4 more miles. So 10 miles above. And this influences weather and climate, as well as drives storm systems. We have all these terms. We have the polar jet, the subtropical jet, and they are constantly moving. And depending on how they interact will determine the weather down here in the troposphere. Because if the polar jet and the subtropical jet, if they collide, then we end up with unstable weather conditions that can yield sometimes pretty funky like a monkey weather. In the wintertime, I'm going to be experiencing, I hope, cold air in the wintertime, while in the summertime, I'm hoping I'm experiencing warm air because the polar jet is still there, but it is moving and shifting based on the fact that cold air dominates in the winter and warm air dominates in the summer. I hope anyway. You also have these terms which, I want to introduce you to them because it relates to the jet stream. You have the term called zonal flow versus meridional flow, meridional, Mediterranean flow. Zonal flow is as you see it, traveling from left to right, like if you're in a zone. Keep going straight down the highway. You're in a zone driving. Just make sure you're not falling asleep while driving. Going from zone A to zone B, just traveling right along. That is air movement going that way. While meridional flow, I just said it, meridional flow has a bow to it. You can have meridional flow with a curve heading south, or you can have meridional flow with a curve towards the north. This curving is based on the air systems being forced towards the north or towards the south in the upper atmosphere. If you have meridional flow at the jet stream level, in this next example, notice how you will end up with a ridge of high pressure over the western tiered states, Arizona, Utah, Wyoming, Colorado, New Mexico, Texas. So that would be a ridge of high, dry air. Meanwhile, that same meridional flow creates something of a roller coaster. So then we have a trough of low pressure extending through not only most of the Midwest, but well into the mid-Atlantic states and some of the southern tiered states. This would be extreme meridional flow. And think about that. If you're riding that as a roller coaster, would that be a heck of a ride? Yeah, I think so. Would it be fun? Well, I mean, on a roller coaster, but in terms of air, I'm not sure if that's a good sort of system for the jet stream. Meanwhile, zonal flow, notice it mostly goes straight across the country. There is an easy divide between the cold and the warm, and there is a nice little barrier that is just pushing the air along without radical conditions. And this next one shows an outrageous meridional flow. Extreme lows on either sides of the continent with a high pressure system dominating most of the Midwest, and it extends really far north into Canada. So this is, extreme meridional flow, and if you have it so that these pressure systems are constantly fighting against each other, extreme low, extreme high, you end up with extreme weather. So meridional flow on a weather map is typically, in my mind, not a good sign for the weather across the country.